What's good, everybody? In today's video, we're looking at how to simplify algebraic expressions, and at the end, I'm going to show you how to do this when we have two fractions with different denominators. Starting off this video, what we need to know is that there's different methods to solve each of these different expressions. So when we look at number one, what we want to do is start off with our greatest common factor and focus on the number values. So if I divide by 7, I'm going to have x to the third power over 3x to the eighth. We could put the 1 there, but it's not necessary. Now, after we've done that, we're going to focus on the exponents. So now we're using that exponent rule. We have 1 over 3, x to the third minus 8. Because we know we're going to have a negative exponent, we could skip this step, meaning x to the negative 5, right, over 3, and just go straight to our answer, which would be 1 over 3x to the fifth power. So just remember that when we're simplifying, start off with your numbers, go to the variables, and remember properties of exponents may be included. Now, this second example, we're focusing on binomials, and specifically right here, we have the difference of squares. So the top part is going to stay the same, x plus 2. And on the bottom, we know the square root of x squared is x, square root of 4 is 2. We're going to rewrite it and just change the signs. So we should have x plus 2 times x minus 2. Now we come over to simplifying fractions, right? If there's something in the top and the bottom, we could cancel it. Oops, wrong one. My bad, guys. All right. So now at this step, guess what? There's something still in the numerator. So we have 1 over x minus 2 as a final answer. Just don't forget that 1 is in the numerator, even if you cancel something out. That's one of the biggest things I see. All right. So we go down to our next example now. And it's similar to problem number 1. So if we start off by simplifying our coefficients, right? Let's see. What can I divide this by? Let's try 4. So if I divide by 4, I'm going to have 4a to the third, b to the third, all over 9a to the fifth, b squared. Now, when I subtract, I know that a is going to probably be in the bottom because this bottom number is greater than the top. So when I simplify, I'm taking that into account. So I'm going to have 4 over 9, right? And let's just do the math. So we have a to the third minus 5. That's equal to a to the negative 2. So let's put that here. And when we do b to the third minus 2, we just get b. We do not need to put the 1. It's understood. So this is going to be our answer right here, but it's not finalized. We got to take care of this negative exponent. And once we do, our answer should be 4b over 9a squared, right? Because we cannot have negative exponents. Now, in our last problem, we're going back to what we call the greatest common factor, but we're factoring with this greatest common factor, right? Instead of reducing the fraction, same thing, but we're also factoring, all right? So now, if I take out 4, this top part changes to a minus 1, close the parentheses. And if I do the same thing in the denominator, I'm going to have 4 on the outside and then a plus 1. Now at this step, we can simplify. We could cancel out the 4's, but the a minus 1 over a plus 1 has to stay the same, or stay there, I should say, because the signs are different. We can't cancel them because they're not exactly the same. But before we go, we're going to do these last two problems where we're combining algebraic expressions with different denominators. You have to remember that a lowest common denominator is needed, or a common denominator is needed for us to add. So that common denominator is 5x plus 1. And for us to properly get the same denominator, we need to remember the bottom to top rule. And all that's saying is, hey, whatever we do to the bottom, we need to do to the top and vice versa. So if I multiply the bottom of this fraction by 2x plus 1, I need to do the same thing to the top. And then when we go to the second part, all we did was add that multiplication of 5 to x plus 1. So I'm going to do the same thing here, multiply by 5. So now I can use one fraction bar, right? Because now we have the same denominator. And I have 2x plus 2 minus 15. Now I combine my like terms. My final answer should be 2x minus 13 all over 5x plus 1, we double check and we notice, hey, can't simplify anymore. This is our final answer. Now, in the second example, we have to be aware, right, that we have a trinomial, meaning we need a factor. And as a tip, typically the other fraction always has at least one of the factors you're looking for, right? I just want to point it out. All right, so we go over here, x squared plus 4. Remember, this was not a negative sign or subtraction sign, meaning the difference of squares. This is prime. Can't factor it anymore. They're going to try to trick you. All right, so now we have x minus 6 times x minus 1, right? Got that figured out. Minus 8 over x minus 6. For us to get the common denominator here, I need to add x minus 1. So I'm going to multiply by x minus 1 in the bottom and the top. Now that I have one fraction, right, with the same denominator, I use one fraction bar. And this is optional, guys. You can keep it separate if you want. I just like to keep it together. So x squared plus 4 stays the same. When we distribute, we have negative 8x plus 8. So now we're focusing on the top because it looks like we have another trinomial and we're going to have to factor. So I have x squared plus, not plus, I'm out of sync, minus 8x, I'm sorry, plus 12 all over x minus 6 times x minus 1. Now, when I break this down to get our final answer, this is what we should have. Let's just get some more space, right? We should have x minus 2 times x minus 6 all over the denominator that we have right here. And as a result, we can cancel and use cancellation, right? So we cancel this with its like term, right? And then our final answer should be x minus 2 all over x minus 1. So when we're simplifying algebraic expressions, guys, just remember if there's more than one fraction, you have to have a common denominator. If we're talking about a single expression, use the greatest common factor, use properties of exponents, and don't forget, you may also just have to regularly factor. Really hope this video was helpful for you guys. Smash the like button, subscribe to our channel for more updates and videos, and comment down below if you had questions, concerns, or anything that you want to know more about this video or future videos on our channel. Thank you guys so much for watching us today.